Alrighty, now on to section 2. So the whole thing on this section is that we're solving radical equations. So every topic we're going to be talking about is just solving a radical equation. They're just going to look a little differently. So as you can see in this example, we actually have two roots instead of one, right? So let's learn how to solve for these. So step 1, we want to isolate the radical, but if the equation has more than one radical, we want to choose one of the radicals to isolate. So as you can see over here, lucky for us, this x plus 15 is already isolated. So we can go on to step 2. So step 1, done. It's already isolated. Step 2, we're going to raise each of the equation to a power equal to the index of the radical. So in this case, when it says, so for step 2, we want to raise the power of the index to the radical that has been isolated, right? So if you are dealing with like the cube root of a radical or something, like 2 and like an index of 2 and 3, you do the one that is isolated. So in this case, x plus 15, the index is 2. So what does that mean? We're going to square both sides. Right? We're going to square it so we know this becomes x plus 15. Right? And over here, so we're still going to FOIL, but this is a perfect square trinomial. So what does that tell us? This tells us this is 1 plus 2 square root of x plus x. Right? 1 squared is 1, square root of x squared is x, and then 2ab, so 2 times 1 times square root of x is 2 square root of x. And that is how we get this part. Right? So technically this is actually step 3 by starting to solve. Okay? So now for step 3, so we're solving the resulting equation, but if the equation still has a radical, repeat steps 1 and 2. Right? So for this, instead of just isolating for x, okay, unlike the previous example, we want to isolate this square root of x. So our goal is to isolate this term. Right? So how do we do that? We're gonna so I'm gonna subtract 1 from both sides, and I'm gonna subtract x from both sides. When I do that, I get 2 square root of x. This is equal to 0x plus 14. Right? And then we're going to divide 2 from both sides, so then we get the square root of x is equal to 7. Right? So now so that was so this is step 3, and then subtracting everything over, that's essentially step 1 because we're isolating the radical. Now we're going to do step 2 again, and then we're going to raise it to each power. We're going to raise it to a power equal to the index. So our index is still 2, so we're going to square all of this. And what does that give us? This gives us x equals 49. Right? So now we have to check our answer. Right? So step 4. And hopefully this time I can do math correctly. So what is this? This is 1 plus the square root of 49. Does this equal the square root of 49 plus 15? Right? So on the left side, we get 1 plus 7, because 7 times 7 is 49, so the square root of 49 is 7. Right? So 49 plus 15, what is that? That is the square root of 64. Right? 1 plus 7 is 8. The square root of 64 is 8. So this is true. Since this is true, this is our solution. Now on to example 2. So example 2, we want to solve for y with the square root of y minus 40 plus square root of y is equal to 4. So for this example, I'm still going to follow the steps, but I'm going to just write it as if I were solving the problem normally. Right? So not putting S1, S2. So when I'm looking at this, so for step 1, we want to isolate the radical. As we can see, both the radicals are on the left side of the equation. So we get to choose which radical we want to isolate. You can isolate either one, right? But for this case, so normally for me, I usually like to isolate the one that has multiple terms first, right? Because I think it's just a little better, but it's up to you. You'll get the same result either way. Okay. So how do I get this by itself? I am going to subtract the square root of y to both sides, so that gives me the 4 minus square root of y. Right. So now I want to get rid of the square root. In order to do that, I will square both sides. When I square both sides, this becomes y minus 40. Over here, this is still a perfect square trinomial, but there's a minus in there. So when I do this, this is 4 squared, which is 16, minus 2ab, so 2 times 4 times square root of y is 8 square root of y, and then square root of y squared, that is y. Right? Since there is still a square root, our goal is to isolate this square root. So what will I do? To isolate this square root, I'm going to subtract y to both sides, and I'm going to subtract 16 to both sides. So maybe I should write it out more. Right? So when I do that, what do I get? I'm left with 0, negative 40 minus 16. What is that? So since they both have the same sign, we're going to add them. So negative 40 minus 16, that is minus 56. This is equal to, so this is 0, and what we're left with is minus 8 square root of y. This is almost isolated, so the last thing we have to do is we have to divide 8 from both sides. When we do that, we get positive 7 equals the square root of y. Right. So now, now we want to get rid of this square root. How do we do that? We are going to square both sides because the index over here is 2. So over here I get 49 is equal to y. Right? So lastly, we have to check. So over here, I get the square root of 49 minus 40 plus the square root of 49. Does this equal 4? Actually, I probably should have brought my book over here. So let me draw an arrow so I can give myself a little more space. Maybe I should give myself even more room, so I'll make the arrow bigger. Okay. So 49 minus 40, that is 9. And then I'll just keep the square root of 49. Is this equal to 4? Right, so the square root of 9 is 3, because 3 squared is 9. The square root of 49 is 7, because 7 squared is 49. Does this equal 4? When we add 3 and 7, we get 10. Is 10 equal to 4? No. Since these do not equal, what does this tell us? This tells us that this equation, this radical equation, has no solution.